Hi, welcome to the section 2.6 notes, and this is on proving angles are congruent. So we're going to review over some of the properties about angles that most of this you learned in chapter 1, and then we're going to use some of these properties along with the properties you learned in the 2.5 day 1 and the 2.5 day 2 notes to do some proofs involving angles. So again, once you've learned one of these definitions or postulates or theorems, then they're kind of fair game to use in a future proof. So the first one we're reviewing over is definition of an angle bisector. So if BD, which we should call that a ray, it didn't come out as a ray. So if ray BD bisects angle ABC, then what do we know from that? We know that, like in this picture down here that you can see, if I know that ray BD is bisecting this big angle ABC, then we know that these two angles must be congruent to each other. So I can say that angle ABD is congruent to angle DBC. And I have to make sure I use 3 letters to name those since there's more than one angle at that spot. The angle addition postulate, which is again similar to the segment addition postulate, just says that the 2 little angles must add up to the big angle. So in this case, measure of angle 1 plus measure of angle 2 has to be equal to the big angle measure of angle ABC. All right, next is definition of supplementary angles. And there's a couple of different ways you can see that definition. If it says if angle A and angle B are supplementary, then what we know from that is that measure of angle A plus measure of angle B must be equal to 180. Okay, but if it starts off saying if the measure of angle A plus the measure of angle B is equal to 180, then I therefore know from that that angle A and angle B are supplementary. And if you remember from section 2.2, I basically have a conditional, and then I just said the converse, basically the opposite statement of that. And we're saying both of those are true for referring to definition of supplementary angles. So same type thing with definition of complementary angles. It also works both ways. If angle C and angle D are complementary, then I know for sure that measure of angle C plus measure of angle D must equal 90. And again, we should have little m's in front here. If the measure of angle C plus the measure of angle D equals 90, then what I know from that is that angle C and angle D must be complementary. Okay, now a few other definitions here. We now have this up here. We already had definition angle bisector, angle addition postulate. Now we're down to definition of right angle. So if angle Y is a right angle, then what I definitely know from that is that measure of angle Y is equal to 90 degrees. So I might need to use that in a proof. Definition of straight angle is if angle Z is a straight angle, then I know for sure that measure of angle Z must be equal to 180 degrees. And then the last one mentioned here is the linear pairs theorem. If 2 angles form a linear pair, then they are supplementary. Because again, if they're 2 angles forming a straight line, then we know that they add up to 180. Okay, moving right along. So the first theorem that we are proving is the vertical angles theorem. So we know that vertical angles are congruent, and that's something we learned in chapter 1, but right now we're doing a proof to show that that is a true statement. So what's given is that now we're going to talk specifically about a picture that we can see that angle 1 and angle 3 are vertical angles, and we want to prove that angle 1 must be congruent to angle 3. But we can't just say they're congruent. We have to prove they're congruent using other things that we know to be true. So like we talked about when we learned how to do a proof, we know that what it stated as given is what we write in the first statement. So angle 1 and angle 3 are vertical angles. Okay, and that first statement is given. Okay, the next thing we can do is we can say, okay, if I look at this picture, one thing that I know for sure is that angle 1 and angle 2 are supplementary to each other. That didn't turn out very good. Let me fix that. Okay, I also can look at the picture and see that angle 2 and angle 3 are definitely supplementary. Okay, so again, once we've used that definition of above, then we're allowed to use it. And we can say that because of the linear pairs theorem. Okay, again, the linear pairs theorem says if two angles form a linear pair, then they are supplementary. I can see in the picture there are two angles forming a straight line, so therefore they must be supplementary. All right, from that, if we say the angles are supplementary, we therefore know that the measure of angle 1 plus the measure of angle 2 must be equal to 180. Okay, and we also know that measure of angle 2 plus measure of angle 3 must be equal to 180. And that is the definition of supplementary. Okay, so if we say they're supplementary, therefore know they add up to 180. All right, from there, we can use the fact that if, this angle 1 and angle 2 equal 180 and angle 2 and angle 3 equal 180, I can take this information and plug it in for the 180. Okay, I'm substituting. If I know that stuff is equal to 180, I can put that stuff in for 180's place. And so then my line becomes measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. And that is substitution. We put something into something else's place. Okay, from there, I can see there's an angle 2 and angle 2 on each side. And if I want to make them go away, I can subtract them away. So I'm left with measure angle 1 is equal to measure of angle 3, and that is subtraction. Okay, and then the last thing is I want to always keep looking at what I'm trying to prove. I've got to keep in mind what I'm trying to prove. And in this case, I can see I've got an equal sign, but I'm trying to prove that there's a congruent sign there. So I can switch from equals to congruent. And when I do that, that is my definition of congruent angles. Okay, anytime you switch from an equal to a congruent or a congruent back to an equal sign. So now that we've proven that vertical angles are congruent, and that's a true thing, we can use that to solve other things. All right, and there's just one little problem here involving that. These little zeros in the picture are supposed to be degree symbols. I think that just didn't come out very well. So again, if we know that these are vertical angles and we know that they are congruent to each other, we can set those equal to each other and solve. And in this case, I solve and I get 10.5. All right, so next proof is not quite as long. And what we're trying to prove here is that all right angles are congruent to each other. Again, that makes sense that all right angles would be congruent, but we can have a proof that shows that for sure. And so if we use a specific example of that in the picture, we see angle 5 and angle 6 are right angles, and that is given to us. If I want to go ahead and mark that on my picture, I can do that. And what I'm trying to prove is that angle 5 is congruent to angle 6. So again, I need to get my given stuff in here first. Angle 5 and angle 6 are right angles. Okay, remember, given is always our first reason. Don't ever miss that. And then now, I have to think, what do I know about that? Well, if I know angle 5 is 90, then or if I know angle 5 is a right angle, I therefore know that the measure of angle 5 must be equal to 90. Same thing with measure of angle 6. I know it must be equal to 90. And that is my definition of right angles. Okay, from there, I can say that if angle 5 is equal to 90 and angle 6 is equal to 90, again, I can take this 6 and plug it in for the 90s place since they're equal. They mean the same thing. So in this case, I can say measure of angle 5 is equal to measure of angle 6. And from there, I'm putting something into something else's place. So I've got substitution. All right, and then from there, I'm switching from the equal sign to the congruent sign and dropping little n's in front. And that is definition of congruent angles, just like we were using definition of congruent segments yesterday. All right, so next up, is we're going to prove this theorem that says all angles complementary to the same angle are congruent. Again, that's another one that kind of makes sense. If two angles are complementary to the same angle, they must be congruent to each other, but we need to prove that. So we're going to start off with saying angle 1 is complementary to angle 2, and angle 3 is complementary to angle 2. So that's our given, and we're trying to prove, therefore, that 1 and 3 must be congruent to each other. Again, think about what complementary means, and it means that it's two angles that add up to 90. So, okay, so in this case, I'm going to get my given stuff in there first. I'm going to say angle 1 is complementary to angle 2, and I can say angle 3 is complementary to angle 2. And that is my given information. Okay, from there, again, you should just kind of start seeing a pattern here. What's something I can say about angle 1 and angle 2 then? More specific than that is I can say that the measure of angle 1 plus the measure of angle 2 is equal to 90. And I can say measure of angle 3 plus measure of angle 2 equals 90. And that is definition of complementary. Okay, from there, again, this should look similar to some things we've already done, is that if I know that angle 3 plus angle 2 is equal to 90, then I know I can put all this stuff in for 90's place right there. I can substitute it. So then I am left with measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 2. And that is substitution. All right, from there, again, keep looking at what you're trying to prove. We're getting there, but we don't want those angle 2's there. So we can make those angle 2's go away. And we can do that by subtraction. Remember, whatever you do to one side of an equation, you have to do to the other. That didn't work out too well. Try again there. Okay, and then again, look at what you're trying to prove. We're close. We just have an equal sign instead of congruent sign, so we need to switch it to angle 1 is congruent to angle 3, and that reason is definition of congruent angles. Okay, so we just have two proofs left. You can do it. You can do it. Hang in there. So this next theorem says that angles supplementary to the same angle are congruent. And it said this proof would look just like the one that we just did, except for the 90's would be 180's instead. So that's just something to keep in mind. And now with this new one, this one is kind of long. The nice thing is they've done some of it for you already. Looks like I'm not. Okay, I was going to reduce the size so you can see this a little bit better. Okay, so it says two angles that are both supplementary and congruent are right angles. So you can see here what's given is that angle A and angle B are supplementary and that angle A is congruent to angle B. And we want to prove that they are right angles. So I'm going to get my given information here. Angle A and angle B are supplementary, and angle A is congruent to angle B. All right, we know that is given. Okay, from there we see that measure of angle A plus measure of angle B is 180, and we know that that is definition of supplementary. Okay, from there, sometimes things don't always just follow in a logical order. Sometimes you go back to the given, and if they've given you multiple things from in the given, then you might use those at a different time later. So it's kind of like the first line of the given, the angle A and angle B are supplementary, led us to line 2, that angle A plus angle B equals 180. But now the second part of the given, angle A is congruent to angle B, is what is leading us to 3, which says the measure of angle A is equal to measure of angle B, and that is definition of congruent angles. Okay, we're just switching from the congruent sign to the equal sign. Now they're basically just combining both of those things. Okay, if angle A plus angle B equals 180, and we know angle A is equal to angle B, then I can put angle B in for the A's place right there. And again, putting something into something else's place means substitution. Okay, from there, I can see that from line 4 to line 5 and became 2 measure of angle B equals 180. So they just took those. And yes, they added them, but it is not the addition property because I can see the 180 from line 4 to line 5 stayed the same. So nothing was added to both sides, so I cannot say addition. So this 2 measure of angle B is just written in a different way than what is in line 4. And so that is just substitution again. All right, from there, we can see that what is being done is dividing by 2 on both sides. Again, you can do whatever you want to an equation as long as you do the same thing on both sides. So we get measure of angle B is equal to 90, and that's the division property. And then from there, now it's turned into measure of angle A is equal to 90. Well, remember earlier we said that angle A and angle B are the same. So in this particular case, they took this A and stuck it in right here for B's place and then ended up with that line. So again, putting something into something else's place is substitution. Okay, and then from there, if we've just said in line 6 and line 7 that angle B is 90 and angle A is 90, then we know that angle A and angle B must be right angles, and that is by the definition of right angle. Okay. All right, good job. You're to the last proof. You've made it this far. Hang in there. So this one says that linear pairs are supplementary. And again, we're just proving that's a true statement. It's called the supplement theorem. What's given is that angle 1 and angle 2 form a linear pair, and therefore we're trying to prove that angle 1 and angle 2 must be supplementary. So go ahead and get your given stuff in there. Okay, from there, if we know angle 1 and angle 2 are a linear pair forming a straight line, then we know that this angle XYZ, must be a straight angle. So I have measure of angle XYZ, make sure the Y is in the middle. This is the vertex. That's equal to 180, and that is the definition of straight angle. Okay, from there, we know that if I look at this picture, I can add up these 2 smaller angles and equal them to the whole big angle. So that's what I'm doing here, is I am saying that the measure of angle 1 plus the measure of angle 2 is equal to measure of angle XYZ. And that is the angle addition postulate. That doesn't look very good. Let's try and fix that. Sorry about that. So, okay, so we got angle addition postulate. There we go. So from there, we can see that, again, if we said the measuring angle XYZ is equal to 180, then we can put this 180 in for the place of angle XYZ. And so in this next line, I can say measure of angle 1 plus measure of angle 2 is equal to 180. And that is substitution. All right, and then the last line is that if we say that angle 1 and angle 2 add up to 180, we therefore know for sure that angle 1 and angle 2 are supplementary. Oh no, oh no. Okay, sorry about that. I kind of closed something on my screen. I thought I lost it, but it's still going, and we are almost done. So hang in there. Kind of move it up just a tad bit. Okay. Sorry for the technical difficulties. So I have angle 1 and angle 2 are supplementary, and my reason is definition of supplementary. Okay, and that's it for that proof. So hopefully you're kind of getting the hang of the proof. Hopefully you're seeing some patterns here. And so, once you get some more practice with it, I think you will just keep getting better at them. Okay, let me know if you have any questions, and have a great day.